There we go. Okay, so the basic outline of the session is going to go through a brief or an introduction to schema.org for those that aren't totally familiar with what it is and how it works and so forth. Go through the harvesting workflow, how typical web harvesters work, and then dive into how best to describe data sets, or one way to describe data sets that makes it easy to harvest. And then hopefully we'll have quite extensive discussion about some of the points and recommendations that come up through the session. And I'll also mention that this is meant to be a conversational session. So if you have any questions or comments throughout this initial presentation, especially later, please speak up. So schema.org is a, excuse me for a sec. So schema.org is a collaborative community activity with a mission to create, maintain, and promote schemas for structured data on the internet. And it's a very general goal, but it's also specific to web pages but also to email messages and beyond. So it's not totally constrained to web pages, but it's also useful for other media that's transferred across the internet as well. So schema.org started with Google, Microsoft, Yahoo, and Yandex as a way of basically driving more structured harvesting of material from the internet. The schema.org is already used widely on the internet by millions of sites, and mostly I'd say by sites which aren't specific to science data, mostly commerce and so forth. Right now, well, since I think 2015, the discussion, the community of schema.org has been hosted on W3C, and those links there provide some more details about how to access and participate and learn about schema.org. So the main goal of schema.org is really to provide a fairly extensive model of objects commonly advertised on the web. So that includes everything from like hotel reservations through to scientific data sets. So you can imagine it's a very sort of broad umbrella. It's basically an RDF model, and it's mostly seems expressed in JSON LD, but that's by no means the only serialization that can be used. It's also highly extensible, which is great because it means you can sort of focus in on specific things that are missing and so forth. But really the most important thing to it from our perspective is that its use for describing and advertising scientific data is still evolving, as you could well understand from the last couple of sessions where fundamental concepts are still being discussed. There's a lot of terms or a lot of types and terms defined in schema.org. There's only a small set that are really directly relevant to scientific data. In particular, we're going to be talking about the data set in this session. And the data set is quite simply a body of structured information describing some topics of interest. That's pretty general. And it extends two other types, one being the base type of thing, and then creative work, and then the data set actually only adds in a couple of properties: distribution, like a link to a data catalog that may be included in an ISSN, which is a very specific item to include there. And then there's two pending terms, measurement technique and variable measured. And these pending terms are interesting because it sort of highlights the process of how schema.org evolves from the community input. And there is a rich discussion, and anybody's welcome to contribute and participate in the schema.org development community by visiting the W3C community page there. There's also, as we've heard in previous talk, bioschemas.org and geoschemas.org, which are more focused specifically on biological and geological terms extensions. So why should we bother with schema.org? I think we've all pretty much understand that it provides more structured information, and so it improves findability of content. And a great example is Google Dataset Search, which is a very general index across data sets in general. And so you can use Google dataset search to find specific structured data sets from, in this case, NOAA weather data. And so why should we bother with additional indexes like Data1, for example? And the main reason is that facilities like Data1 and other science-focused indexes can really focus in on the precision and recall necessary for scientific data reuse and discovery. And it's something that Google is unlikely to venture into too much detail on providing that level of precision that's needed. So you always get more general search results with systems like Google. So besides improving findability, it also facilitates data access by providing programmatic support for accessing the metadata. It enhances interoperability by providing well-described resources, and it promotes reuse through simplified programmatic access. So exposing schema.org metadata is really very simple to do. You can add it to your existing web pages as a JSON LD script section that's just in the head section of the HTML. Another way to add schema.org metadata is to use a federation like Data1, for example, which automatically adds in schema.org markup to content that we have harvested from other repositories. So if you're participating in Data1, then one value add is that you get schema.org generated as a byproduct of that participation. All right, so what does it look like? So here's a great example of a data access site, BecoDemo. And this is what you call essentially a landing page for a data set. And contained within that is the really interesting part, which is the markup. And when it comes down to it, the schema.org markup is as simple as just ensuring that you're adding in a JSON LD structure within the head section of the HTML page. Now, of course, there's specific structure that needs to be followed for defining this JSON LD, and that's what we're going to be talking about for the rest of this session. Interestingly, there's lots of different syntaxes you can use for expressing the schema.org markup. JSON LD is probably the most favorable because it's generally the easiest to understand, and it's easy to use with different parsers and so forth. And so as I'm going through this discussion, I'm going to point out a few recommendations. And these recommendations are just things that we've observed from Data1's perspective and generally in the community. They're by no means rules. They're just like suggestions, and they're open for discussion as well. So the first recommendation is that we strongly prefer JSON LD as a mechanism for serializing the schema.org markup in the landing pages. As you're working with adding in schema.org to your pages, or if you're just curious about finding what schema.org is available in sites, then there's a couple of web-based tools which are really handy for this. One is the structured data testing tool provided by Google. Another is JSON LD Playground. There's a couple of command line tools. One that we find very useful in Data1 is called Extract. That's a Python library and command line tool, which basically you give it a URL and it spits out the JSON LD. It's great. Another is Gleaner, which has been developed in the EarthCube project 418. Just to show a quick example of what the structured data testing tool shows you. Oops, is that not coming up? So this is a BecoDemo data set, and you can see that basically you give it the URL to the data set, to the data set landing page, and of course the structured data testing tool will pass the HTML, identify the schema.org markup in there, and pass that and present it to you, and also highlight any errors or missing components. So it's a great tool for just like quickly testing whether or not your stuff is working effectively. Okay, then the this extract tool, if you're a command line junkie, then it looks kind of like this when it spits out the results. So basically, you just give it a URL, and it'll download that URL, pull out the JSON LD and other schema.org markup, and present it to you in a nice JSON structure on the command line, which you can then feed into other tools like JQ, for example, to further process that and pull out pieces of interesting information. So adding schema.org to your pages is pretty simple. Viewing it is also pretty simple with tools which can actually process it. And then how do you go about actually the basic process for harvesting a site? Again, this is also pretty simple, and it relies a lot on best practices for exposing content for web harvesting. And it starts off with the very basic thing of the robots.txt file. Now, this is an optional component, but it's really handy because if robots.txt is set up properly, then all you need to know is the domain name for a resource that you want to harvest. And then you can go to that domain name. The robots.txt file is always located in a particular location at a particular URL. And so you can download that, and then you can read that file, and you can see that the sitemap is located at data/sitemap.xml in this case. So then you know where to go to download the sitemap. The sitemap gives you the list of resources that are exposed by that server. And it's a very simple XML document that contains a list of URLs plus the timestamp for when that resource was last modified. So if you come back in a couple of days, then you know you can ignore stuff that has a last modified date older than since you last visited. And so then the next step, once you have these URLs pointing to the landing pages for the data sets in this case, then you can just iterate through that list, download the resource that's identified in the sitemap XML file, and pass that, and there's your JSON LD or schema.org markup in that. So it's a very simple process. Just if things are set up properly with the robots.txt file and the sitemap.xml file, then it's very easy to discover these resources from exposed by the repository with very little initial information. And the really nice thing, of course, about schema.org markup is that it's super easy to parse and figure out, what this thing's talking about. Okay, so this basic process for harvesting is commonly used by web crawlers around the world. It's essentially the same by all the big indexes. There's a few tricks that you can shortcut things and so forth once you learn where sitemaps are, but following that basic pattern is really helpful for anybody that wants to figure out where the content is on your site. And it really relies on this progressive introspection of providing more information as you dive deeper into the system. And there's a bunch of tools that are available to both produce and consume the sitemaps and the other pieces there. Okay, so the second recommendation that comes out of that is that generally speaking, we should follow the widely used practices that support web introspection for discovering these resources. Okay, back to the schema.org dataset thing. And we're going to go through a little bit of the details associated with the dataset structure and how, and some common practices or things that we've seen in Data One as being useful to help indexers figure out how to interpret those data. Okay, so at the top level, you can imagine that the schema.org markup can be basically an exact replacement for example, ISO metadata. It could be possible to translate the entire ISO and the entire ISO 19115 document into schema.org. That's not to say you should do that, but it's probably possible to. Instead, I think it's more useful to think of the schema.org markup as providing information that's useful for discovery primarily, and then rely on the availability on the richer metadata schemes like ISO and EML and so forth as providing the metadata that's really useful for reuse and interoperability of those, describing those data sets. So at the highest level, you can see the data set structure here. It's, well, we've all seen this in the previous presentations, but basically it's a type of data set. In this case, it has an ID which uniquely identifies this particular node in the RDF graph. Oops, pardon me. We have a name, description, URL, where this thing can be downloaded. Also really important to include in the markup is any relations to other known instances of this thing. So it makes it much easier to dedupe resources if they're being harvested by multiple locations, by multiple harvesters, for example, and so forth. Now this type of schema.org can be generated. There's tools available to generate this from existing metadata. So if you already have EML or ISO, or maybe not EML so much, I'm not sure if there's a tool available for, there is kind of, for turning the metadata into schema.org, but there is for ISO 19115 for at least a portion of the schema, DCAT, Dublin Core, and Darwin Core, for example. So it's basically pretty easy if you have that existing metadata to transform that into the schema.org that gets embedded in the landing pages that you're advertising for the data sets. And the amount of the metadata that gets transformed into the schema.org should be really sufficient to facilitate discovery. So it should contain the terms that really help people discover your data set in the millions of data sets that are potentially out there. So the fourth recommendation is pretty obvious, really, is that you should include as much of the metadata as you can in the schema.org markup. Okay. So in the situation where you have, say, an ISO metadata document, and the ISO metadata document provides a really rich description of a data set, why not just reuse that information, expose that information to a harvester so that if they choose, they can retrieve that metadata document and parse it and pull out the richer information. It's actually a little bit challenging to do that in a way that is semantically meaningful in the terms of schema.org, because you have to basically rely on some assumptions of best practices of use of how to provide that relation to the metadata. One approach that we've found is quite effective is to use this encoding, which is basically saying an encoding of this dataset metadata is available at this location, and it's in this format, and there's a human readable description there which says it's the TC211 rendering of the metadata. That provides sufficient information to a crawler, such as Data1, for example, to know where to go to retrieve the rich metadata describing that data set. So that sort of points to the last step in this sequence of harvesting, which is after you retrieve the schema.org, you need to have enough information to know where to go to get the rich metadata. And in this case, it's a ISO metadata document. And so that points to the next recommendation, which is basically to, when you have this metadata available, the rich metadata available, point to it and or reference it in the schema.org markup so that crawlers can find that and download it and reuse it. Now, schema.org is also, of course, quite extensible since it's an RDF model, and there's lots of existing vocabularies that we can reuse and to point to additional constraints or additional classes that you need to describe. And one in particular that's quite useful is to reference the data site ontology. And this is useful because the data site ontology can provide a precise definition of what type of identifier is being used in this case, which is, in this case, it's a DOI, and it's a well-known type defined, or there's a control vocabulary identified in the data site ontology schema that precisely identifies this type of thing. So a consumer knows that this is definitely a DOI, and there's certain things you can do with a DOI, for example. Right. So the next obvious recommendation is to reference well-established ontologies and vocabularies to reduce ambiguity when you need to reference specific types of terms. Now, there's lots of different ways to structure a data set. In the Data One Federation, we've taken an approach of a fairly granular mechanism which identifies metadata, describing data, and that the relationship between the data and the metadata is sort of bound by a OAI ORE RDF document, which defines those relationships. So basically, it's a very flexible structure for describing static data. And it's one that's we've found it's worked quite well across all the different repositories that we've worked with in Data One. So one question is, how do you express this type of structure in schema.org? To simplify that view a little bit, it basically comes down to having the metadata document at the top there, and one or more data components of the data set down the bottom, with the manifest, which is the Open Archives Initiative object reuse and embedding document, RDF document, that sort of binds everything together. And it provides a very tight coupling between the components of the data set. So when we're harvesting content, say from Pangea, for example, we want to make sure that we transfer all that data set structure along with it, so that when we then subsequently make that available through Data One, that we ensure that the relationships that are between the data and the metadata and so forth are transferred across, so there's no loss of information as far as the structure. One suggestion, one way you can do that in schema.org, it's fairly effective, is to use the has part property. And the has part is basically a list of elements that are of data download types. So basically what this is saying is that this data set, in this case, has one component which is downloadable at a specific URL. And then that component itself has its own identifier, and the encoding format, in this case, it just says data format, but that would be a controlled term which identifies the specific type of the data that's being downloaded. And there can be multiple entries in the schema.org markup. So basically you have a list, you can have a list of data components that are described by this metadata and available for download. It's very easy to process. It's a very simple and flexible way of doing it. We understand that there's lots of different ways of doing this, but this is just one approach that works well for us so far. And it is something of an implied structure. There's no specific components in this that says that the metadata actually documents that data. It's kind of implied by its presence within that same markup, but it's a fairly solid implication. Another common thing that we index in Data One is actually data that's available through a service of some sort. Services are much more difficult to describe because there's lots of different types of endpoints for services. And there's a couple of examples in the Science on Schema.org repository and documents, which kind of walk you through examples of how to describe service endpoints within Schema.org markup. But I'd say this is probably the part of this process which is, let's say, there's room for more work on defining it appropriately because it's such a complicated thing to work with. But the final the final recommendation that comes out of that is that, where possible, provide an explicit reference to the components of the data set. Kind of makes sense, because now, given, if you think about it, starting with just a domain name, you can now go all the way down to all the components of all the data sets which are advertised by that repository, just by following this simple trail of information which is expressed through this Schemaorg markup. Oops. Okay, so in summary of this sort of really fast, high-level overview of Schemaorg, we can say that the path to adoption is really super simple. Oh, how'd that happen? Where's my mouse gone? Huh. Okay, that's a mystery. Hang on, I have to exit the. Yeah. Okay, we're back. I'm not sure what happened there, but we'll go with it. So anyway, Schemaorg, it's super lightweight. It's easy to work with. The devil is in the details, of course, as far as actually generating Schemaorg markup that is going to be universally useful across for harvesters and your clients who you're producing this for in the first place. And so it's really important, I think, that as a community we come together and provide some guidelines for, especially for data repositories, as far as the best way or some best practices for implementing Schemaorg in a way that is most easily ingestible and reusable. By indexes is one use case, but also by other users that may want to actually directly access and reuse the data. There has to be sufficient information for a client to be able to access and understand what they're accessing from the repository, and whether or not it's applicable for a particular purpose. One thing that we can do as a community, if there's parts of Schema.org that don't align well with our practices as a community, then we certainly have a loud enough voice to go to the Schema.org maintainers and suggest for changes, and that's already happened in a number of cases already. And so it's really important to realize that this isn't a static thing. It's something that we as a community can evolve according to our requirements. But it really is kind of emerging as a kind of lingua franca for sharing of structured knowledge about anything on the web. And that's that basic pattern of harvesting and accessing the resources, which I described earlier, applies to pretty much any resource that you're describing through Schema.org. So it's not specific to data sets, it works with pretty much anything else. So once you've adopted that methodology for exposing resources, you can use it across other things like documents and calendars and all that sort of stuff as well. There are a few challenges. One in particular is we need to be very careful about reusing identifiers where possible. We've seen in a number of cases where the identifiers that are expressed in the Schema.org markup aren't necessarily the same identifiers that are used in citation or exposed through even through the landing pages for data sets. So that creates a situation where there's potentially multiple identifiers for the same thing, and it's really hard to figure out which one is the actual identifier you should be using.
So I noticed in your example that you use URL as an item as its identifier. Is that your recommended practice?
No, that's just one example of an identifier that was used. So
that's guaranteed to be a unique identifier, where people, I think what you're doing is people with all kinds of things.
Hang on a second, I need a microphone.
So the question was, I saw in your example that you were using the URL for the item as the ID for the item, which is guaranteed to be unique. And is that a best practice?
It's a practice. I wouldn't say it's a best practice.
Well, okay. Well, maybe it looks like a suggestion, but I know a lot of people would put other things in there, and so I think the gist of this is that you're suggesting that the identifiers be unique, right?
Unique and persistent.
Right, which leads to the idea that maybe it is a best practice to use the URL. Questionable, but
that's.
Can I just comment on that too? So, I mean, there's a long debate over whether URIs are persistent and URLs in particular. So there's certainly a whole community within the data and within the data repository world that have, used DOIs and other types of persistent URIs that don't necessarily only get expressed in URL form. And we see those across all of the repositories that we're interacting with, both URNs, ARCs, the RRIDs, DOIs. There's a whole litany of alternative identifier formats, and I don't think we should legislate away from using those.
So to even complicate things further, right? So the semantic web version of this would be cool URIs, right? Yeah. And that we want to separate the thing in the world, right? Either using a hash or a redirect. Both of those have all kinds of issues, right? From the information object that's returned about the thing, right? Which would be the landing page, right? And so that might be an argument for having a distinction of some sort, whether, whatever mechanism by which it ends up being blessed, because all these things have issues. And I think that a lot of other organizations are trying to figure this out. And there's some potential in the OGC work in Selfie of trying to resolve some of this about how to identify a thing in the world versus the information objects about the thing in the world, right? And so I think that also leads back into this discussion of unique identifiers, right?
Hi, Dave Blodgett, US Geological Survey. You got to introduce yourself, everybody. I was called out, Selfie was called out, so I'm going to say something. If the ID doesn't come with the type of ID, then a URL is better than anything, because schema.org in particular, and the mass market is going to want to go look that thing up, and you got to have a resolution mechanism, and HTTP is the only one we got. So,
well, the protocols.
All we got to do is start talking about identifiers, and bam.
Actually, I'm not even going to talk about identifiers because that's a topic that is truly fraught. But actually, I noticed several other things that I kind of have questions about. And so I think there's a minimum of 3 there, I think. We'll see if I forget them by the time I get to the last one. But in any case, the first thing is about this idea of a encoding. Because the inverse of encoding is encodes creative work, which is the work itself. And is the work the data set or it's metadata? If it's the data set, then we haven't done things right yet. If it's the metadata, that means there's at least 2 creative works here. One, the data set, and the other, it's metadata. So that's one thing that's coming to mind, is that separation of concepts. Maybe I've been doing semantics too much lately. Anyway, part 2, similar to that. I mean, you have the concept of a map, a site map. How does that work in the world, such as NSIDC, where they don't actually have any real landing pages? They're just created on the fly as you hit a URL that comes back from a search engine. This was actually an interesting thing that NSIDC had to solve when I had them do their schema.org stuff about 5-6 years ago. But I don't think the world has gotten better since then. So the concept of a sitemap and how that works with services is an interesting thing you might want to think about. And lastly, I understand why Data One does the whole OAI ORE thing. And in fact, I've actually looked at that in detail for like Modus with I actually had ESIP-funded Little Funding Friday project about 6 years ago on that topic. The issues there are all about, okay, so most of those data sets are growing continually. And they're now up to like having, 6 million or so granules per data set. And a granule might have like 6 or 8 things in it. And there is granule level metadata as well as data set level metadata. And above that, there might be instrument level metadata and mission level metadata. And this whole hierarchy of stuff, which OAI, ORE ought to be good at dealing with, but I don't see how any of that really maps well here yet, or whether it even should.
Yeah, those are all really good points. So the first one is about the encoding point. And yeah, I agree. It's hard to, I mean, we need to agree as a community, I think, as to what we're actually describing when we say this is a data set piece of schema.org. And the specification is kind of loose in its description of what that actually means. You can interpret it both ways. You could say that the encoding is the encoding of the creative work described by the schema.org metadata, or you can say that the encoding is a particular encoding of the metadata itself that is the schema.org document. We're choosing the latter of those in that it's an alternate encoding of the schema.org markup, basically. We're doing that because there's another mechanism which lets you point to other components, if you like, of the data set. And in fact, if you wanted to, I think in Bico Demo, correct me if I'm wrong, Adam, but I think I've seen a couple of cases there at least where the data download is actually pointing to another packaging structure, which is described in JSON, and then that in turn points to the various components of the data set itself. So it's there's multiple ways to do it. This just seems to be one way that's without too much shoehorning seems to fit the practices that we've seen so far, at least. Okay, then the second one was what was the second one?
I was going to talk about the third one, so.
Oh.
Go ahead.
No, you had 3. Oh, okay.
So maybe I'll do a quick, just address the ORE thing. So we chose OREs because it was a nice packaging standard that's been around for a long time, widely used in the library community. We don't think it's the only way you can build a manifest that does, built for building data set hierarchies. The nice thing about ORE aggregations is that they are inherently hierarchical. So you can build a hierarchy of data packages in an internet-friendly way, a web-friendly way through OREs. I totally agree with you that the scalability issue is a big one with that, and we've struggled with, if you've got millions of granules in a hierarchy, ORE we do have trouble, dealing with that in a timely way, and so that is a challenge. So I think the schema.org entry on a landing page actually has a lot of similarities to what we're describing as an ORE aggregation, and I think they're relatively isomorphic as kind of a manifest of what's contained in the data set. Can I get Nathan first? He had his hand up. Oh, you want to respond?
Yeah. Actually, I like OAI ORE. You just have to be careful how you implement it. And there are times when it might not be the best thing, if you know what I mean. And now I've lost the fourth thing. Oh, no, I do. You mentioned how the community has to get together to do this stuff, right?
Sure.
Well, I agree with you totally. And I think we just defined in the previous session where that should happen, which is the ESIP's brand new schema.org cluster. So that's just a plug for anybody who's interested in the answers to any of these questions to join that.
Okay, so this is Nathan Potter, and so I just want to throw this thing out there. I don't know if it's commonly known, but I've had quite the email exchange with Natasha Noy in the last month around data that I was trying to get into their system. And this is the thing. If your metadata document is larger than 2.5 megabytes, it will be ignored. So be clear about that. This is a challenge. There's data sets with 1,100 variables. And by the time you get done iterating, you know, variable measured, variable measured, variable measured, you're out of gas, man. And so this is a real challenge. Now, this is a place where, you know, Doug and I are talking about how maybe it can be resolved. It's, you know, with some of this work, because it looks like Google's not, she's just like, that's how it is. We're not changing that. And so you'll find that out quickly at that test page, because if you put a larger document into it, it'll just balk.
Yeah, and just a comment on a presentation that we had on Schemaorg with one of the SciTech committees, right? And so there was some interesting questions that were raised during that time in terms of the keyword, right? So the keyword is the key sort of entry point for the Google semantic recognizer to figure out what the entities that are there in relation to the knowledge graph plus the description. And the overwhelming recommendation that came out of that phone call, right, was that you should reformat your underlying metadata into the description objects so that the natural language processing engine can then do entity extraction based on the knowledge graph and then essentially import that information back into the Google search, right? And so there's this round tripping that's going on also that worries me quite a bit, right? And so I think that's another set of discussions that need to be had with Google, because there's already knowledge graphs that are aligned even in some ways, right? So I showed this morning Wikidata. So Wikidata is essentially the knowledge graph. It's an old version of the knowledge graph, but it's the knowledge graph, right? And that was an entity for that place in Switzerland, right? And so there's already mechanisms here by which they could do this crosswalking much more sensibly, I think. So.
Thanks. One small comment on the what are we identifying, and what is the information object and all that. I suppose from the history of schema.org itself, these are historically metadata schemas for web pages. They're actually describing, this is a web page that's about a recipe, that's about a service or a data set. Now, of course, we're using it in all sorts of other ways, but that's why there is a sort of, that's in its DNA, that's what they're using it for. I kind of had a question, I suppose, for discussion, but we'll ask Matt and Dave. There are two components to this kind of architecture. There's the schema.org payload, and then there's the web crawling protocol for going and getting it. And first, I should just note, great supporter of schema.org. We've implemented everything, but have you thought about separating those two out and, delivering other kinds of metadata, using the web crawling, DCAT, or putting, if we're doing really specific scientific aggregations, have you thought about using the DCAT alternative or other specific alternatives and just delivering them through the web crawling thing? Or the other alternative, if we're not crawling the whole web, and I just know the number of repositories and I just want to pick up the metadata, we could deliver schema.org using that as the lingua franca, but have an agreed open API or something like that would probably give you better performance, rather than having to go in and what's the word, dereference it, or at least read the header of the HTTP header of each page of what could be quite big repositories.
So I'll just quickly address that. So within Data 1, we do support many different metadata dialects, including all the sort of standard XML-based ones. And I think Dave's slides where he showed where we're using schema.org as a lightweight way to basically find and locate these resources that are described as data sets. And then what we're really hoping is that people provide that linkage to the more detailed structured metadata that they already have that might have this, much longer list of variables and other detailed metadata that Google won't like, and that probably isn't going to be in the schema.org record anyways. So, we have multi-megabyte and sometimes even 10 megabyte ISO documents coming in for data sets that describe extensive structures. And so what we're doing is parsing the schema.org, using that to find the linkages out to the associated metadata. And what we'd like is a really nice vocabulary in schema.org to make sure it's clear to us what the relationship is between that entry and any other referenced or linked entries that provide additional structured information. And a DCAT entry would be a great example. If there's the schema.org, but there might also be a DCAT entry or any other vocabulary that we can pull from. So we're totally willing, and we sort of acknowledge that we live in a very heterogeneous standards world, and there's a huge range of things that are out there, and we should be pulling from all of them to build these aggregated catalogs. And we shouldn't limit ourselves to the just one vocabulary like schema.org. The benefit behind it is basically as a lightweight, common way to discover the existence at first is great because Google's just, everybody's motivated to put that out there. And so all of a sudden we have this directory that we can sort of jump on top of. So Dave, you want to sort of highlight the recommendations and discussion questions and see where we go with that?
Yeah, sure. So, well, we've got a list of recommendations which emerged as I went through the presentation.
Can you zoom in like another couple levels?
Okay. How's that? Is that legible? All right. So to summarize the recommendations, first one is basically we prefer, well, I think it's general recommendation that JSON LD should be the syntax used for encoding the schema.org markup in the landing pages. Next, it's really helpful if
Dave,
yeah.
So I think you went through these before, and I saw immediately after you started saying that one, there was a series of reactions over here.
Oh, okay.
And I wonder if we should just like ask people to react to these, but also throw out others that, like, if we as a community want to set up a candidate list to be discussed in this new schema.org working group, what would they be? Because
yeah, I'll point out this is just basically a straw man list. It's by no means set in stone. It's whatever you guys suggest as being workable, we'll go with it. So first one, JSON LD.
So I guess I want to throw out something to think about here. Again, Dave Blodgett, USGS. I'm working on the second environmental link features interoperability experiment. And so there was a comment, I don't remember who said it, about round tripping to natural language and back so that the natural language processing and machine learning that the mass market search infrastructure uses can make sense of our content. And we can't ignore that because that's the machine learning part. That's the smarts that nobody understands because it's a statistical, low level, high powered thing that they've created, and we can hack at that. We can figure out how to take advantage of that. But we need to experiment just like everybody else does to figure out why machine learning algorithms work the way they do, right? But then there's the schema.org. So that's one side of the problem, and then there's this other side, which is the schema.org and structured knowledge. And I think that there is a conversation to be had with the search engine development community at large about expanding the scope of structured knowledge that is allowed into their algorithms, right? Because no doubt they have some trump cards in those algorithms that are based on schema.org tags, right? And they probably have some RDFS, and they probably have some OWL, and they probably have some other things that they found and thought was fun to put in, right? and maybe we can join them and add some of our stuff that we think is really important, like suite, et cetera, right? And then we don't have to just sit here and talk about schema.org as the structured content that we put into the JSON element of our landing pages, right? And anyways, we can engineer our way through this problem, and that's the last thing I'll say. Sorry, is at the Geosemantic Symposium, Simon Cox gave a presentation, and I raised my hand and said maybe over beers we should talk about this. And I think it's something really important to consider here. And it's this is a bit of a reaction to somebody who said that the schema.org definition of a data set is kind of ill-defined. The schema.org definition of everything is ill-defined. It's defined by its usage, right? We define those tags because they're tools for the community to use to be precise in how we express our documentation, right? And anyways, don't worry about the schema.org definition. Get all your data out there and redefine schema.org, right?
Dave, you know Ruth, right? Yeah. Yeah, so I mean, Ruth made this, what I consider to be, an interesting but rather obscure question about does encoding is there more than one creative work, or is there one? And Dave is proposing an encoding for metadata, and he just shrugged. So what you're saying is, if we want encoding to be an encoding of metadata that describes some other creative work, which is the data set itself, that's fine. We just define it that way and sort of screw the schema.org definition. Is that interpretation of what you said correct? And how does that contrast with sort of, or where does that fit in terms of Ruth's question of sort of, because I sort of worry about this stuff when I'm designing metadata. What is this thing actually describing? And but is the encode, I sort of like the encoding proposal that Dave made, but am I interpreting what you said correctly in terms of those other two comments? Does that question make sense? Okay.
Mm-hmm.
No, that's not what I meant. That wasn't what I meant at all. The point I was making was that the meaning of a schema.org concept, right, is defined by how it gets used in the wild, not necessarily by the definition as written in schema.org or how interpreted by you when you read it, which has nothing to do with duplication of identifiers and what's one copy of a data set versus what's another copy.
I think that's a kind of a dangerous assertion. I mean, I think certainly there's loose definitions or loose descriptions for concepts in schema.org for sure, which can be interpreted many different ways. But I think there's certainly a bounding scope that we need to work within. I think that's your intent, is that once we as a community establish sufficient momentum behind one interpretation of a concept, then that's going to dominate, right?
So just a quick comment about schema.org's real intent, right? So schema.org's real intent is to discover affordances, right? What are businesses? What are their times? Can I present that to you? What are your travel information, right? What are entities in the world and their links to the knowledge graph so I can create knowledge panels about that person, right? And so those are the things that have actually rich applications and are actually being used. And I suspect that deep inside Google, they have thought through those sorts of things because they have to build applications off of them, and they have built applications off of them. Now, I think that the other sorts of tags are probably used, in terms of their indexing of web content, discovery engines. They are used for the search sorts of things, not necessarily application things, but the search sorts of things, right? And that's a little bit more of a black box, right? Because we don't know as much about how that presents itself to the world just because we don't see any indication of it. That's the magic thing. When you type a string, it goes off to magic Google land and you get a result which may or may not be what you're looking for, right? And so those are the two sorts of things that we can sort of infer about Google and their knowledge vault. I mean, they actually call it a knowledge vault because it's sort of opaque, right, as to what they're doing underneath it, right? And so that's how I would sort of view this, is that this is in a sense an affordance to Google, right? That there's a thing in the world called a data set, and I can present that as a knowledge object to somebody that's searching for something, but not necessarily infer anything beyond that. Okay, so that's one way to view it, possibly.
And so I'm going to go with Steele and then Pierre. And I'll note that I've also talked with Natasha about this issue of like, can we influence the way Google search works? And her answer is generally no, that not only can we not influence that, the Google dataset search team cannot influence that because they're just using the larger product that's built around a commercial use case that is completely swamps everything we're trying to do in terms of importance to them. So yes, sacrosanct, right?
So I just wanted to make what's maybe just a philosophical point, but one of the reasons we invent formal languages is to avoid the ambiguities of natural languages. And so I guess I'm a little nervous about saying, let's let our formal languages behave and be interpreted and evolve and be flexible in the way that natural languages are. It seems like a lot of work to try to inject semantics that will allow us to have machines talk to each other and that sort of thing, to just go, let's treat these like natural, or, let them behave and live and exist as if they're just natural languages. So I don't know what to do with that, but I guess I reject the notion that we should allow people to misuse our formal languages in the way we allow them to misuse natural language.
So is schema.org a formal language?
I mean, if schema.org, I mean, it doesn't have the formality that we need as a Earth observers, ocean observers. On the other hand, in a sense, I think you need both. I mean, if you have people using natural language strings and you just want to see what happens, and then cluster that and see how the world is talking about something without any formal control, cool. That's a research subject in itself. We need that because we want to know how Malaysia understands forest and how the US understands forest and its citizenry. But on the other hand, if we have an expert community that needs to be precise about what exactly they mean with something, then they should have the option to use formal language support. So being able to then reference an IRI and say, look, this is exactly what we mean, is needed by a subset of the community. And I'll say, we've been here before. This is the gene ontology story all over again. When people started calling genes hedgehog or buzz1 or something like that, they were sub-communities of people who used that word to talk to the same gene. And that's why, again, this was needed. A formal representation to say, here's an IRI on the web, that's exactly what you mean, call it whatever you want, but point to that. And so with both of those things, we get a powerful set. We get ML capacities, where you have lots of people talking about the same things in roughly the same way, and then knowledge representation, or ontology, or whatever capacities, to help disambiguate things where you have a lot of experts that always disagree about something. So, we need to just think of a collective strategy here.
Getting back to the data set definition sort of thing, I actually had 3 things, and we'll see if I can remember all 3 of them by the time I'm done with this. So my takeaway from what Dave said was less we should just go run wild with what data set means and use it for whatever purposes we have for it, and more that our community probably has a particular definition, or actually our community almost certainly has multiple definitions of data sets if we actually get down to it, and that's an active research question, a thing that we need to actually figure out for ourselves. So that's a conversation that we could be having here at ESIP. And if you're bored on Friday morning, could have at the conceptual modeling session that me and Nick Weber will be running. So I didn't see it as a running wild. I think it sounds like it's something that we should be thinking about. What are our conflicting definitions of data set just within this room? And The second thing that I want to point out, we're talking a lot about Google for we're talking a lot about Google. And I think it might be worth remembering that we don't have to be wedded to Google. So Project 418 was an example of a search engine that is not Google. And it might be, if it continues to fail our use cases, then it might be worth thinking about what other kinds of search engines we can make ourselves, or how we can leverage existing portals like, I guess it's GCMD, to better make use of schema.org or existing aggregators, existing metadata harvesters. So I just wanted to put that out there. And I have forgotten the third thing that I want to say. So
I'll just follow up that that's the reason why Dave and I wanted to have this conversation, because we're trying to build a search engine that's useful and goes beyond the kind of level of search that Google does. Another conversation I had with Natasha was about where they're planning on going with domain-specific search. And her answer was they're not. That they're not going to put in the ability for you to like go to a specific area. They might use geospatial location in their heuristic, but they're not going to give somebody a bounding box tool to say, I only want things in this particular region. They're not going to give people a parameter search to say, every result that comes back must meet this specific semantic type for a parameter. So I think it's incumbent upon the community to develop the search engines that we think are necessary for the science needs. But I think Beth, you had another comment?
Yeah, I just wanted to circle back to what Pierre was saying, that I think in the formal language side of things, the fact that a community says, here's what I mean, here's what we mean by forest. I mean, this is why we have namespaces to some extent. This is what we mean by it. If that's not what you mean, you should, put your own addition to the ontology or the vocabulary. So I think it's not to say that everybody has to agree about what forests are like or something, but rather to say that if you don't agree with me, that's okay. But for this formal purpose, you can't talk like me because people will misunderstand you. And so yeah, anyway, I think it doesn't mean that we have to throw out certain concepts and not allow people to have those concepts. We just have to be really careful about how we refer to them. And that's what formal languages are about.
Hey, so if we're going to say that Google doesn't meet our needs with respect to searching and returning metadata about data, then let's really at least try to focus on using schema.org to get to have Google represent services so that we can at least get it to go to our services that do these good subject matter expertise area searches and capabilities.
So this conversation has been really, it's really interesting because it's at a very high level and kind of philosophical about how we handle the formality of schema.org as a formal language. And I think that's one level at which we can approach this. But another level at which we can approach it is the very pragmatic view that everybody's rallied around schema.org because Google has supported it. So even though we like to say that that's not why, but that's really why we all have schema.org entries on all of our dataset landing pages. And so because of that, we can leverage that into a more interoperable system than we've ever been able to achieve before. And so one of the things we could do is to say, yes, let's continue down the path of semantic formality and continue our experiments and how we can get the community together on that. But at the same time, what are the practical small steps we can take to reach agreement on some of the use of the vocabulary to build better search systems and better harvesters around this? And so like one of the examples that I'll give that's a super practical thing, but kind of frustrating, is that when people register data sets with Data One, they'll oftentimes use an identifier. And when they register that same data set through a schema.org page, they use a different identifier. And they don't provide a linkage between those to say that they're the same data set. And so when we go to publish that data set, republish and basically put our schema.org entry on the page, we use the identifier that they provided to us. And Google now thinks there's 2 copies of that data set out there. We would like to not do that. And we need guidance and recommendations to repositories to say, it would be good for you to list all of your identifiers and and indicate equivalence using, you know, the standard recommended mechanism for that. And so there's a whole litany of practical things like that, that I think if we could just get simple agreement on those without solving the world's semantics problems, just like if we could get those kinds of things ironed out, we'd make a big leap forward in sort of consistency. And even within Google dataset search, things would be much more, it would be more apparent why things are being linked together.
I just want to ask a question. I mean, who in the room actually uses Google Dataset Search? Like, who uses Google Dataset Search? I mean, we've probably got 2 people in the entire room, right? And you found that, you know, it's not particularly feature rich, right? I don't think designing for Google Dataset Searches get any real future, to be honest with you. I think we should be designing with the intention that what we're embedding here is available through google.com search, right? That's the primary effort. That's where the disconnection is here. The other thing as well is that I don't think that we have sufficient uptake and rollout of schema.org across the entire community right now. At NASA, it's only at Earth Data Search, PODAC, and maybe ORNL. There's another 10, even in Earth science data centers there that have not uptaken it yet. I think we're expecting a whole bunch of stuff here. We've got excellent recommendations, but where I think the proposed cluster could really focus on is combining maybe this with science and schema.org geo schemas, whatever it's going to be, and focusing on that, and then proposed extensions which have been discussed throughout today, and let the rest kind of roll out. And what I'm talking about is we had mentioned we were planning on taking it to the ESIP program committee, and people had said, great, we would like to roll that out at the data center, but we need like a tutorial, we need a video, we need something like this. So where the real low-hanging fruit, I think, is for the new cluster is to package this into something which is the go-to resource, like a 1-hour video or whatever it is, experiences of people that have rolled it out, and then we start really getting some uptake, because I'm not entirely convinced that a lot of people, maybe with the exception of Data One and the data centers that you guys harvest from, but I'm just not entirely sure that there's really been that much uptake right now.
I don't know that there's a lot of data centers that have done that uptake, but I do know of a list of, I think it's 84 or so polar data centers that are waiting anxiously for best practices and instructions, because they see this and simple tooling, because a lot of these data centers don't have any technology people, but if you have a tool like the 418 folks were creating to, you know, create a metadata record, a schema.org type record, they would be able to put that in a web page about their data set. You know, so when I talk about simple, I mean really simple. Fill out some fields in a form, hopefully with lots of drop downs, and and they're done pretty much. But they really want to do this because they've been trying now for 20 years to get a federated search across all the polar data centers that there are. And they have not been able to do it because of the technology differences and semantic differences across that entire community. But this at least gives them a very, I mean, I don't really honestly don't care about anything beyond parameter, space, and time. If you can get to that, then I call it good enough. And you can do that in schema.org.
You know, I mean, one thing, and Dave and I have talked about this, and I've talked with Matt about it as well. You know, I think one thing that may be an opportunity, well, to step back to just a second, right? As Adam and I went into the second phase of the work we were doing with EarthCube, one of the problems I think we kind of faced was how do we incentivize the data facilities to re-engage with us, right? That did it originally in 418, right? We had about a dozen facilities originally in 418 that worked with us, and why did they work with us? Is what Matt said, right? It's because they want to be in Google Dataset Search, right? It wasn't because Adam and I were working with them, right? You know, they care less, right? And so then when we came around, we said like, well, how do we re-incentivize these facilities, even the ones that did it originally, to make sure those things are updated and things like that, and not just that they said, oh, you know, schema.org, done, move on, right? You know, and so one of the things Dave and I have talked about, Matt and everyone, is the ability to do these kind of validation of these things through the shapes graphs. And I think that one of the things that we might be able to do relatively easily is take the Google required and Google recommended types and parameters and form shapes around those, and then analyze, process the facilities that are exposing JSON LD and get back to them and say, hey, good job, but you know, maybe there's some things like the way you're encoding IDs, which we had about 12 facilities involved, and I think about 15 different ways IDs were encoded, and provide that as a way back. And what we can do then is provide incentives for those facilities to say, we can improve our metadata, we can do better with Google, and in reality, what they're doing is doing better with everyone, right? Whether it's Data One or other groups or things like that. So I think that's a fairly simple thing. We have a lot of that tooling in place, and it's something that, you know, you could give to a facility and say, run this on your robots.txt or sitemap.xml and see what your report is. And we can give that to them as a human, right? As a human type report, because there's a very nice PyShackle library that does a really nice job doing that. So that's just an idea that we could throw out.
Yeah, and I think that we should go beyond the Google recommended types, and whatever this working group comes up with, you know, this idea of the minimum set of recommendations for what facilities should do. If it's in, yeah, sure. But there's already some good ones in science on schema.org that should be added there and stuff. So do you have a comment?
Doug's comments just kind of got me thinking about some certain things. Even though I haven't been using the data set search much, except for just trying out to see what was out there, what I have used a lot of is Google Scholar. When I go looking for papers, or I look for citations of papers or citations of citations. And what occurred to me is that if Google doesn't treat data set search development as a dead end, but are actually thinking of what they could do with it beyond that, what if we could actually make it possible for us to specify data sets that Google could then make connections to papers in Google Scholar? We can finally close that loop of where research gets back to the data that got it started. And then the possibility of integrating it with their Earth science tools.
Just a quick comment. Top Grade has actually released all of schema.org as a shapefile. So there's already work on taking the existing schema.org and generating a shape representation for validation. So exactly. Exactly, yeah.
Mm-hmm. Yeah, and that's really nice, that top grade exposure of that. And we've used it within Data One already to evaluate some of the stuff, but we find that it's we need more constraints, because with schema.org there's lots of ways. Pardon me. There's lots of ways of representing essentially the same information, and so by just providing some slightly high or tighter constraints on those shackle graphs, I think it'll be able to provide enough feedback to the community that you know, this is a best practice that we can follow, and if we do, then it makes it that much more interoperable. Absolutely. Yep. Yep.
So I would add one more thing with the graph, the shape kind of concept and all that, and adding in a domain specific search, because we, Nathan and I have been comparing notes over here. We do need domain specific search, and Google's not going to do it for us. And we do actually want to use the same architecture that Google uses. And what I'm saying in that is we want to use domain specific markup with our structured content that Google doesn't care about, so that we can use it in our community crawlers and search engine harvesters and et cetera, right? So stay tuned to what's going to come out of, you know, various projects, but the one I'm working on with Alistair here, we're coming up with a mishmash of schema.org and stuff that schema.org doesn't do. that's going to allow us to do some more advanced, sophisticated things, and we'll see where that goes. I just, from a very practical perspective, we got a lot to build on that's not schema.org that we can do. So.
And I'd say there's a lot of vocabularies already in use that we could make use of. The challenge we have, I think, is dealing with the problem Nathan was talking about, that you can't make your schema.org entry too big or else it doesn't serve the purpose of the Google. So I think if we established a really nice linking mechanism where we can really identify that here's the core sort of catalog entry in schema.org, but it's very clear how you make that next step to the domain specific extensions and where those might be that won't interfere with that catalog function.
So two comments. So that then requires publishing vocabularies, these things as dereferenceable linked data sorts of things, as I alluded to in my talk earlier today, right? Because then that lets you jump from the limited bits that you can get from schema.org to something that's more expressive, right? Okay, so that's sort of point one. Point two is that bioschemas, so there's a bunch of other people have sort of concluded the same thing. So if you look at bioschemas, like they absolutely know that a chemical entity, no one, Google's not going to pick that up, right? And there's really good ontologies about chemical entities, right? PubChem has some really good Chebby, all these really nice sorts of ontologies, right? And so that's also the approach that pragmatically they're taking, right? So there's other communities that we can look at and say, hey, they're thinking along the same lines, right? So.
Wow, we got a lull. Oh, wait, Peter is, you okay up? You doing all right?
I think I lost circulation in my leg there for a bit. Actually, I think this is for Adam and Doug. Google has not released their API for the dataset search, have they? That's what you should be asking them about, because they release APIs for lots of other things, and that would then let you use whatever they can provide. And Roll did this 8-9 years ago with a thing called Noesis, which was searching for things across publications and data repositories and Wikipedia, and sort of doing this sort of information integration. So please work on them. I'll do it as well. But
so when we were at a Polar Data forum that Ruth was talking about, where we were discussing the federated search for Polar repositories, I did ask Natasha Noy that. And she said explicitly they have no plans on releasing a public API to let people get to the underlying harvested data that they're doing. Because we were wondering whether we could just bootstrap and leverage the Google index to build more specific search systems on it. And maybe that's changed, but.
So she's instructed to say that? If you ever talk to someone from Google and you ask them something, 99 times out of 100, they will say, no, we're not going to do it, or there's no plans. And then they do. And they do, and they had no plans to put up the structured data testing tool either, until this community and a couple of others came to them and showed them that they were marking up content. And so maybe, it's the pull model we might want to explore. So don't get discouraged if you ask for something. I've asked for a whole bunch of things, and I know they're on a list for sure. So keep asking.
And maybe if a lot of us ask, it'll change the equation.
Okay, so moving forward, it seems like there's a lot of interest in schema.org in general, and we've got this new group starting within ESIP to sort of focus more on this particular topic. I'm not sure exactly what the next steps are for that group as far as formal engagements and so forth, but I think it'd be great to set some short-term goals, which may include some initial recommendations for just to help people that are publishing content now to help converge any differences there. And then also look at the longer-term goals as far as how far can we take schema.org to provide a level of interoperability across all of the ESIP participants.
Sorry, I had to step out for a sec. So I don't know if you mentioned this, but I was talking to Adam and Doug before and mentioned that in other topical areas like this in ESIP, we've got to the point where it's become the need is split between the expert track and the education outreach track. And I suggested to them that I think it's time for tutorials for schema.org. These guys have the basis of it. John Ralph gave a little bit of one with examples. And I think what you've got now, because it really comes at sort of the education level, and then pitch it to a slightly different audience. And that would be very valuable in an ESIP setting. And then we would drag those people in, and then, you know, they come up to speed, you know, all the usual things.
Yeah, I think also having a couple of tools which are easy to use, like Gleaner and some examples of validation type tools, just things that you can verify that you're following best practices and so forth, I think would be really helpful as far as, you know, pushing things forward.
I just wanted to echo what Peter said, especially as someone who teaches data curation classes. So the reason I'm sitting in these sessions today is because I teach my master's students, you know, schema.org is important. You need to know how this works. And I would love to have somebody else's slide deck to work with and tutorials for that sort of thing.
Yeah. So just to comment on it, there's actually a GitHub issue that was discussion on whether we should call this on science on schema.org or if we should call this geoschemas or whatever. And I actually put a comment there that we should actually have both, right? And the science on schema.orgs should be the place where there's tutorials, where there's templates, where there's examples, where people can come in and actually see what's going on. But we also need a geoschemas.org where we can basically provide functionality that is a benefit to the community that doesn't necessarily feed back into exactly schema.org and provides, you know, added benefit, right? And so that's why I think we actually need both. So I don't know what the actual decision on that is, but if you vote on GitHub topics, put a thumbs up on that comment, and maybe that will lead to I don't know, something.
Sorry, I must have just woken up. Who made the comment about Google Scholar? So I was just checking on permafrost because it's Ruth's favorite test. And on when I did that, one of the first data sets that came up was from NSIDC. And there were, right under the title, there are 3 papers in Google Scholar that cite this data set. So that suggests that there's at least a one way. I think all you're saying is, you know, maybe it'd be nice to have something the other way, but where's Adrian? Scholix, right?
Well, let me comment on that too. So the Make Data Count project has been working between Crossref and DataCite to try to establish those kind of linkages, sort of building on the Scholix work, but also for usage metrics and other types of metrics. And I think that the message that they're trying to get out is that both publishers are failing to basically provide the linkages in DataCite metadata back to datasets, and repositories are failing to basically put linkages back to published papers that are associated with their datasets. And we need both communities to be providing those structured linkages. And right now, the main place where people get that kind of stuff is through the relationship type in DataCite metadata associated with DOIs. So there's certainly a lot of other types of identifier types that we use in this community, but at least if you're talking about DOI identified resources, just putting that linkage in goes a huge way in being able to create that, establish that relationship in a way that everybody can consume. Feel free.
That kind of suggests that one thing we could look at in the geoschemas is how do you actually create those kind of cross references in schema.org metadata, because right now it doesn't actually have a good mechanism for doing that.
Yeah, that's a good point.
We've only got like a few minutes left here.
Yeah, we've got 3 minutes left to the top of the hour. So, anybody want a final word?
So I'll just say this has been a really encouraging conversation to me, because I'll get you in just a second, because I think it seems like there's just a lot of support around the idea that we can come up with a common set of standards, and that using the ESIP cluster to do so, that always involves people volunteering time to actually go there, help put in issues, help comment on issues, and sort of work out what those agreements are. And so hopefully we'll have enough momentum going into this and can just follow up on what Doug and Adam have started over on the GitHub areas in ESIP, and continue working on this. Is somebody going to start sort of a series of calls on this specific topic or something, or how are we going to kick this off? Adam is, okay.
Yeah, right. No, it's totally cool. So yeah, all right, we're gonna start a cluster. The email is off to Mike Daniels, who is the person who can sort of set up the cluster infrastructure for us. I have one question here. So how often should that cluster meet? In my experiences running clusters, a once a month meeting doesn't quite do it, especially when you have a summer and a winter meeting. You tend to not meet those months, so 10 meetings a year is probably not enough to do it. And so I would like to see more, but I'm curious for feedback on that. How often do we want to chat about this?
The last word, okay, you got it.
Matt's getting a good workout here. That's great.
So my thought on that is just learning from our experience in the sort of cryosphere hackathon vocamp work that's now a cluster, right? Is that to be productive on these calls, right? We need some organization, some topics, and some activities about what we're actually going to do, right? And so I think what we should do is maybe sit down and figure out what a good topic for the first steps that we think that this can accomplish, right? So I think one is just the mechanistics of, okay, we've got geoschemas.org. What platform is that actually going to be? We want to make sure that that anything that gets pushed to is dereferenceable. Do we want to borrow bioschemas have this sort of pipeline? Is that appropriate for what we want to do? So those sorts of things, and then you can build out from there. So, all right.
I have 4 words. Let me see if I can remember them. Yeah, no, I know, but oh no, shoot, it's 5 words. Use case, scope, milestones, charter. Go. That's 6.
That's very true.
Hey everyone, my name is Shane Glass. I'm the public data sets program manager at Google Cloud. This has been an awesome discussion. I asked to have the last word because I didn't want to interrupt the conversation that was going on about the cluster being spun up. But I just want to kind of put a note out there from the dataset search team is that dataset search is designed to be this like very lowest common denominator, right? And that it's not going to meet the needs. It can't meet the needs of every specific domain. And so from our perspective, it has to be as flexible as possible so that it can meet the needs of the science community, but also of the sports data community, right? And kind of everything in between. So where we kind of run into these limitations of saying, I have a data sets with 17,000 variables. I think from our perspective, our goal is to get people to, we rely on those domain specific repositories at that point. So our goal is let's get them to the right repository, and then that repository can serve the needs of the community from there. And so I think that's kind of really the objective that the dataset search team has gone after, and just trying to get people to the right place to discover the right data in the first place, instead of saying, hey, I'm looking for oceanography data. Why am I in a space weather repository? Because there wasn't a markup language to get you even to the right repository. So it's not necessarily designed to be a fix for everything, but at least help people get to the fix for each thing, if that makes sense. So but this was an awesome discussion. I appreciate the opportunity to join in.
Yeah, thank you. The question that was just asked is,
Yeah, so the question was, are we going to provide an API? Am I going to provide an API? No, but that's not what I do for a living. There's no plan to do so right now. And I recognize the point earlier was that, and I hear you. I mean, there legitimately is no plan to do it. Now, that's not to say we won't do it. It's to say that we're not planning to do it today. And so if it's done in the future, that means we changed our mind. Not necessarily that someone told me to say something that is, the right answer. But even if we were planning to do it, I would have said no just because it would be funny. So I can tell you there's no plan to do so now. I'm not saying it won't be done. I'm saying that as far as I can see, or as any of us can see today, it won't be done.
All right.
so I'm going to let Lewis here have in his Scottish brogue.
Thank you. There is a document which exists, which is intent is to formalize this stuff. I'd mentioned it a couple of times. Formalize this stuff, send it to the ESIP program committee, and get it essentially endorsed by the entire federation. And I do think that guidance on data set and data repository is ready for that. What I would hate to see here is that the cluster doesn't push that sometime soon, and we'll wait like a year, or in the case of the data citation stuff, it's 10 years later before there's another revision. It would be nice to see this maybe go through 5, 6, 7, or however many multiple ESIP-wide reviews or program committee reviews. There's no reason why that couldn't happen, because I think we're talking about services, service handoff. Well, that's just merely an addition to data set, data repository, services, and then there might be something else, and there might be something else. That's just a bit of guidance that I would like to put out there.
Okay. Well, thank you very much, everybody. Really appreciate all the comments and feedback here. And thank you, and we'll see how things progress in the ESIP working group. And thanks to Matt for running around the room many laps.